Hello, my Algebra 1 students. We are in Lesson 51 today, and we're going to talk some more about the Cartesian coordinate system and linear equations. When we have what we know as a linear equation, which just means we have a constant and an x and another constant and a y term equal to some number, then we know that and they're both to the first degree, we know, maybe you're not familiar with it yet, but you will find out that this will graph a straight line. And as a result, that's why we call this a linear equation. When x is to the 1 power and y is to the 1 power, and that's the only variables you have, you can graph a straight line out of this. So that is why we call this a linear equation. And my pen is not wanting to respond this morning. It's apparently too early. Linear. Okay, a linear equation. When you have the same type of equation and either x or y is squared, it becomes a different type of a line. It's not a straight line anymore. So those are not called, they have a different name. We're not going to go into those yet. Right now, we're only going to worry about linear equations. We won't worry about any of the other types for quite a while, so don't worry about those. So with a linear equation, the first thing we have to do is we have to put it into a format that will allow us to graph the line. So let's look at how we would find out how to graph that line. So in order for this to be graphed, I'm going to erase this right here and give you an actual problem. We are going to do 51.1, and we're going to graph this linear equation. And whenever you are looking for a linear equation, or whenever you're looking for a way to graph, we have to put it in a specific format, and that format is called slope-intercept format. Slope-intercept format is specifically a linear equation that is solved for y. So we always want to solve for y by itself when we have a linear equation. That tells us what y is. Now, because we're solving for y is going to depend on whatever point we put in for x. So the x determines the y. So that means that x is going to be our independent point, our independent value, and y is going to depend entirely on whatever we choose for x. So y is the dependent. All right, so put that down, that x is the independent value. If I can get this pen to work. Independent value. And y is the dependent value. It is dependent on x. All right, so let me tell you or show you what I mean by that. I'll move this up here for you. All right, what I mean by that is when we are given a linear equation and we're asked to graph that line, we have to figure out what are the points on that line. How do we determine the points? Well, the way we do that is we start by making a table. So I'm going to make a table here for x. First, I have to get my pen back. This is x value. This is our equation, 2x minus 1. And then this is going to be our y value. So we're going to pick some values for x. All right, and I always start with 0. I start with 0 for x because if you put 0 in for x, whatever is here goes away, and your y just ends up being this number on the end. So that's an easy one to do. You don't really have to do any math. So this would be 0 minus 1 would be -1 for y. And so what we would do is we would come over here and we would turn that into an ordered pair. And our ordered pair would look like 0, -1, because this is our x value and this is our y value. So we would look on the x-axis, here's 0. The very center where the two cross, that's 0, 0. Let me use red to graph this. So if we want to graph 0, -1, we come to 0 on the x-axis, and then we come down to -1 on the y-axis. So that's going to be our first point, is 0, -1. And we label it. All right. So now to graph the line, we need to find another point. So I'm just going to choose 1 as my next point, and I'm going to choose another point too. I'm going to choose 2 as my other. So we put this into what's called the, what is this called? It's called the machine, some type of machine, function machine. So I put in 1 for x, 2 times 1 becomes 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 leaves 1. So our next point would be the x value is 1 and the y value is 1. So you can see why the y value is dependent upon what we choose for the x value, and why we say that x is independent, because we get to pick it. We can pick whatever we want. It's an independent value. It doesn't matter. We could say this was 7 if we wanted to. That'd be fine. But if we choose 1, we put it into this domain function, or this function machine, we get 2 minus 1. Y has to be 1, because that's what the formula or the equation tells it has to be. Now, if we select 2 as our x, we would say 2, we would substitute in 2 minus 1. 2 times 2 is 4, minus 1 is 3. So our point here would be 2 and 3. So now let's go ahead and graph this point 1 and 1. So we go to 1 on the x-axis and positive 1 on the y-axis, and we put our point here and we label it 1, 1, just like that. Now let's graph this point, and it's going to be 2 on the x-axis and 1, 2, 3 on the y-axis, and we label this point 2, 3. Now we have a line. We have a line. So we start up here, and then we draw through the points down here. And I'm gonna, yeah, there we go. And we always put a little arrow on each end because it can go on and on and on. All right, so that is how we draw a line using our linear equation. We set up a table just like this, and we have an x value. We have our little equation formula that we use to determine what the y value is. We pick some values for x, and then we perform our calculation, and it spits out y. And the first one is always the easiest one, because if we choose 0, then the first one is given to us over here, because this would cancel. 0 cancels out anything here. So whatever this number is going to be the y value. We call this point with the 0, this is the Y-intercept point. And it's called the Y-intercept. If I can get this pen to write today, it is crazy. It's jumping all over the place. I probably need a new tip on my pen. Cursive just seems to do better for some reason. We call this the Y-intercept because this is where the line crosses the y-axis. Okay, you see this y-axis? Wherever the line, the point at which the line crosses the y-axis is our y-intercept point. Okay? And that is why we call this the y-intercept linear equation. When we solve for y, it tells us what the intercept point on y is going to be when x is at 0. Because when x is at 0, this is the point that it crosses the line. So these are the points that the parts we need to worry about. This has an absolute format. And the format for this, it's technically called slope intercept format. And the format is y equals mx plus b. And as long as your line is in this format, as long as you have solved for y and you have x first, your x term first, you can look at this linear equation and know certain things. And we're not going to go into all of the things right now, but recognize that whatever this plus b is right here is going to be the value of your y when x is 0. That's really all you need to know right now. We're going to go into more of this later. So let's solve another one. Let's do 51.2. Let's use a different color. Let's use blue for this line. All right, this line is y equals 1/2, or it's negative 1/2 x. And remember how, and it's plus 2. Remember how I said when we are dealing with fractions that the negative is never in the denominator? This is part of why the negative is never in the denominator. Part of which is because your denominator just tells you how many parts you have to make a whole. So it's like a label. It's not an actual count. It just tells you got to have 2 parts to make a 1 whole for this fraction here. And your 2 parts, you don't have those 2 parts, and you're also missing another. That's what the negative 1 means. All right, so the reason I say that is because in a linear equation also, the negative means something when it's in the numerator. It means when you have a negative numerator right here in this little spot, it means that your line is going to slope a certain direction. So in 51.1, this was a positive sign, all right, positive 2, and our line sloped up. With this negative number here, our line is going to slope down. Just the sign can have that much importance. So let's look at how that works. So let's do our x. Let's do our negative 1/2 x plus 2, and then we'll do our y. We'll draw our table right here. Now, let's pick 0 for the first point, just because it's easy, and we know that if we put 0 times this, it's going to be 0 plus 2. Come on, pen. So y has to be 2. We didn't even have to really do any math. We could see, because it's this point right here, that y, when x is 0, is going to be this positive 2. So our first point is going to be 0, 2. So let's graph, well, first let's do our table, then we'll graph all those points. All right, so something that you should pay attention to, when you have a fraction right here next to x, it is a whole lot easier to calculate whatever this value is into whole numbers whenever you pick a multiple of the bottom of the denominator. If I were to pick 1, I would say, and put it in for x, I would have to say 1 times 1/2 plus 2, which would give me 1.5, and I'd have to graph 1.5. Well, if you notice, all the points on your graph are whole numbers. So you'd have to come about halfway in between, and it's hard to be exactly right when you're using a fraction as a coordinate point. It's a lot easier to use a whole number. So whenever you choose points for x, look at the denominator and choose a multiple of that. So my next x coordinate, I'm going to choose 2, and then for my next one, I'm going to choose 4 because it's multiples of 2. And now I'm going to plug those numbers in and have it tell me what y is. All right, so when I put in -1/2, and I put in 2 plus 2, 2 times a -1 is going to be a -2. -2 over 2, that's going to be a -1. So -1 plus 2 leaves a 1. So my next point is going to be 2, 1. All right, when I plug in 4, all that substitution that y'all have been learning how to do is for this reason right here. All right, when I plug in the 4, I say 4 times -1, that's a -4, divided by 2, that's a -2, plus 2 gives me 0. So my third point is going to be 4, 0. So let's graph these points. We have a 0, 2. So we have a 0 on the x-axis and a 2 on the y-axis. That is my intercept point. So that is going to be 0, 2. You always label your points. Always, always, always. My next point is 2, 1. So I go to 2 on the x-axis and I go to 1 on the y-axis. So I just go up 1, right? And that's going to be 2, 1. And that's why I'm using different colors, so you can see the different lines. And that's something that you can do on your homework. I'll give you the option to have different markers when necessary. And when you're taking notes, it's a good idea to use different colors as well so you can see the different lines. So this is an opportunity to make your homework look pretty and have some different colors and get all creative, which, you know, I like. You might not like that. It's okay. So our third point is 4 and 0. So we go to the 4 on the x-axis, and the 0 on the y is right here on the x-axis. So we're right here. So we have 4 and 0 for this point. That's supposed to be a 0 right there. So now we can draw our line. And if you notice the pattern here, you can go back up here to this pattern and it'll help you to draw your line. You guys will have less difficulty with this on paper than I will on here because you can just put a straight edge down. But when you're doing it on the computer, like on your homework on the pods, it's not going to automatically straighten. It's just going to be whatever you draw. So just do your best. When you're doing a line on Jupiter Ed, you're graphing a line on that, I am not going to care as much about how straight your line is. I'm going to care about, do you have the right points and are they labeled? That's what I'm checking for. And then you draw your line as straight as you can make it. I know it's tough to do that on a computer. I have a tablet with a pen and I still have trouble sometimes. So put your little arrows on your line. And there is your line. And as you can see, I told you beforehand that this negative would make this line slope downward. So that is something that you need to be aware of and double check. If I were to have a line that had gone up, I would know something was wrong, that I didn't do my calculations correctly because this was a negative sign. Because that tells me, okay, from left to right, it's going to go down if it's negative. And from left to right, it's going to go up if it's positive. So I need to be aware of that to make sure when I finish drawing my line that it's in the right direction. That should be a clue for you to see when you've made a mistake, or to see when something's just not right and you need to go back and redo it. All right, so I think we have another one to do. Yes, we have 51.3. Let's do that one in green. 51.3. Let's do it right here. And we honestly don't need these quadrant identifiers when we're graphing. I just put them in here because I thought it was fun. I'm going to take them out now because they're a little bit distracting. There we go. Let's do this one in green. 51.3. Actually, I think I'm going to do him a little bit higher. Yeah, let's do him right here. 51.3. And this is a little bit different. It's still a linear equation, but it says y equals negative x. Notice we don't have a number over here for our b. So what does that mean? Oh my goodness. So what that means is that the value that we choose for x is going to be the opposite value for y. So let's look at that. So here's our table. I'm going to do it right here. Let's do x here. And then this is our value for y, negative x. And then this is our y. Okay, this is our formula in the middle. We always choose 0 for x. Negative, if we put 0 in for negative x, you can't have a negative 0. So y is just 0. So our first point is going to be 0, 0. All right, let's choose 1 for our x value. So negative x is negative 1. So y is negative 1. So our next point is going to be 1, negative 1. And because this is a negative x value, our line should slope downhill, right? From left to right, it should go down just like our previous line because our previous was negative. Let's choose 2 for the next x value. So negative 2 for the x, y should equal negative 2. So this point is going to be 2, negative 2. So you see how that works? Whatever we plug in for x, y is just the opposite number. So let's see how that graphs out. So we start with 0, 0 as our first point, and I'm going to label it here. 0, 0. Our next point is 1, negative 1. All right, I'm going to label that 1, negative 1. And then our next point is 2, negative 2. So we go 1, 2 on the x-axis, and then down, because it's negative, 1, 2 on the y-axis. So now we have this downhill line, which is the correct line. Now, why did it do that? I hate it when it does a ellipse for whatever reason. I'm going to erase that. Not sure why it does it. Sometimes it just jumps around. I like this computer system, this software, but sometimes it does funky things. All right, so let me draw that line back. So here is, there's our line. So here was our point, 0, 0, 1, negative 1, and this was our 2, negative 2 point. Let me put my arrows on my line because the line goes on eternally in either direction. But as you can see, it is a downhill line from left to right. This proves true. When it's a negative x value, the line goes down. So that's something that you can see proven in these last two problems. Let's see if we have any more. These are kind of fun. Once you get started with them, you get to graphing these. These can be kind of fun. All right, so let's look. We have one more that I want to do on this page before I draw a new page. Let's do a different color this time. Let's do this kind of, let's do orange so it'll stand out. So we have another line, and we are told for 51.4 that x is equal to -2. What? There's no y value. How do we solve this when there's no y? What this line means is that it doesn't matter what y is. Y can be any number whatsoever. X is always going to be -2. So for every value of y, x is still going to be -2. So what that means is we don't have any points to map. All we have is a line to draw. We get a straight line. Let me make it straight. This is not quite straight. We map our line straight up and down on the -2s. That's it. When we have x is equal to -2, we find -2 on the x-axis, and we just draw a line straight up and down, and that's it. We're done. No table, no points to figure out. All we need to do for this is say x equals -2, and that's how we would label that line. We would put that on the graph right next to it. And when you use, like I said, when you use a color for each line that you draw, if you're drawing more than one line on a Cartesian coordinate system, then it helps you to see the points and the labels for that line. It's much easier to see that this point goes with this label goes with this point instead of this one because of the color. When you use the colors to correspond with the points on the line, it does help you see the difference. So keep that in mind when you're taking notes. Color coding can sometimes help make things a little bit more clear. So that was super easy, wasn't it? So let's see if we have another one like that. We could probably graph one more like that on this chart if we have one. And we do. Let's pick another completely different color from what we have. Let's pick this hot pink color right here. And we have a line that is 51.5. And it says that y is equal to 4. Wait a minute. We don't have an x value now. This one didn't have a y. This one doesn't have an x. When we don't have an x, that means that it doesn't matter what the value of x is. Just like for this line, we go to the 4 on the y-axis, and we just go all the way across. We pick a couple of these points, and it helps us to draw a line right through. We just make sure we do some points that have y. We draw our little arrows on the end, and then we write above the line y equals 4. And what that means is it doesn't matter. X could be -6, x could be +3, x could be +8, x could be -8. Y is always going to equal 4. Just like x always equals -2, y always equals 4. So when you're given a linear equation and you are told that it's x is equal to this, you're going to have a horizontal line. It is going to be straight up and down. Not a horizontal. I'm sorry. Sometimes I get those words mixed up. You get a vertical, straight up and down. What's funny is your x equals is going to give you a line parallel to the y-axis. And your y equals is going to give you a line parallel to the x-axis. But it's going to be on the y-axis, and this is going to be on the x-axis. So those are all the situations where you're going to see straight lines. X equals or y equals. All right, let's see if we have one more. All right, since we only have one more, I'm not going to draw a new graph for that. I'm just going to pick a completely different color. Let's do purple. We haven't done anything purple. So let's do this one. We are going to graph y equals 2x. All right, so this is 2. We have for 51.6, we are told to graph y equals 2x and y equals 2. Well, y equals 2 is easy. We know what that is. We come over here on the y-axis and we go to the 2. We pick a couple more points on the 2 and we just draw a straight line on the 2 across the y-axis. That one's done. Y equals 2. Easy peasy. Check. We did that one. But now we got to do this one. So for this one, x does have a formula here. It's 2 times whatever x is the value of y, but there is no intercept given. When there is no intercept given, you can say plus 0. That first intercept is going to be 0. So let me show you why that's true. If we have x, 2x, and let me write that over a little bit. I'm going to put 2x in the middle. And then this is our y. We have our little chart here. All right. Let me redraw this line. This bothers me. All right. So if I pick 0 for my first one, 0 times 2 is going to be 0. So y is 0. All right. That's 2 times 0 is 0. Isn't that the same thing as that b that we had when we said plus b? Isn't that plus 0? Yeah, we're not adding anything to it. It doesn't hurt anything. So our first point is 0, 0. Just like here. We could have said plus 0 here, and it would have been true. Whatever x is, y would have been 0. It doesn't change it to add nothing. But it does help you to see your first point of 0, 0 when there is no b value in your linear equation. So let's finish working the rest of these. So let's choose another point here. Let's choose 1 and let's choose 2. I just like to choose easy points to calculate because whatever number you pick is what you have to calculate. And if you pick small numbers, you can do them in your head and you don't need a calculator. So 2 times 1 is 2, right? And then 2 times the x value of 2 is 4. So this point is 0, 0. As we've already pointed out. So 0, 0 here. And the next point is going to be 1, 2. And then the next point is going to be 2, 4. So you can see whatever we pick for x, the y is double that. Let me write this where you can see it a little bit better. It looks a little wonky. There we go. So just double the first one, which is what this does for y. So 1, 2, 1, positive 2 is our next. Oh, hang on, that's wrong. It's supposed to be a 1, 1, 2 is that point. And then 2, 4. So 2, 4 is our next point. And so then we would just draw a line right through those points. There's our line. Just like that. How about that? We have our points labeled. Oh, I didn't label this one. 2, 4. So we have our line labeled with our points. And we have our line drawn. All right. If you notice, excuse me, the red line that we have here, look over here. We have the same x value, 2x, as we do on this right here. Look how they're parallel. So when you have x values in two linear equations that completely match, you're going to get parallel lines. We learned something. All right, we'll go more into that later. You don't have to worry about that so much right now. We'll talk about parallel lines on the graph system much, much later in the book. But right now, I just thought it would be fun to point that out. So I know this is very confusing. It's a lot of different colors and lines going on. But if you will split them up, put them on different graphs. You do need graph paper at this point. You can put as many as you want. If you use different colors, you can put more on one graph than if you don't. If you use the same color, it's hard to do more than 2 on the same chart before it gets really confusing. So that's why I use different colors, so I didn't have to draw a different chart for you guys for every line, because that's a little bit time consuming when y'all are waiting on me to explain something. But you can go back yourself and rewatch the video and pause it long enough to give yourself time to draw a new little graph on your graph paper if you're not using different colors. The most important thing that I want you to take from this lesson is that when you see a linear equation like this, it should be a signal to draw your function machine so that we can calculate 0 and y points and then be able to write your points and then take those points and put them on the Cartesian coordinate system. You know that this is the x value and this is the y value. Always, always, x is first. And then be able to draw your line by putting these points and then connecting them. That's the main thing you need to know about this lesson. Remember that x is independent because you get to pick whatever x is. And therefore, y is dependent on whatever you pick for x, because you have to plug it into this formula or this equation to figure out what your y point is. Okay? That is the main things for this lesson. All of this will come later. We'll talk constantly about it over the next few weeks. So I will see you guys in lesson 52.